didn't sign up for that.
That's Tim Gorman in the background. Thank you very much. Cary and I talked, I don't know, several months ago about him having a slot at the conference here, and as we got talking about it, we decided that maybe it might be interesting to have sort of just a sit-down chat as opposed to a stand-up presentation. So through the course of those conversations, that's what we decided we were going to do. Many of you guys know Cary Millsap and his history. Cary's a very humble guy, so and not in the form that Winston Churchill would say, because he's got a lot to be humble about, but he's a very humble man. So those of you who are not familiar with him, and I'm sure that there's probably not many in the audience that aren't, should know that Cary's has a long history as a performance architect, performance with Oracle guy, and so he had a big impact on me personally in my career, and really influenced the way pretty much everybody that works in that arena, I think, thinks about the way they do their job. And so the reason I thought it would be interesting to have this chat was because Exadata is a different sort of technology and a big change in the way Oracle does things. And so I thought it would just be interesting to talk to a guy that's a long-term performance guy to just see what he thinks about it. What do you think about the things that have changed in it? And so that was the motivation for it. Cary and I both like to have audience interaction. So as we're sitting here having this chat, if you have any questions, don't be shy about raising your hand and asking. It's a very small group here, so it'd be easy to do that, I think. So any questions before we start? Oh, I'm Cary Osborne. Many of you probably know who I am already as well. I'm a longtime Oracle performance guy too, but I've been doing Exadata almost exclusively for the last 2.5 years or so. So we bought a V2 pretty much when they first came out and have it in our lab. We expanded it to an X2, and so we've had it apart with our screwdrivers and put it back together. So that's my background. That was Tanel asking the question, by the way. So my first question for Cary was going to be to tell us a little bit about your background, and I think I'll let you do that, even though I've already said a little bit about your background. But
yeah, you did that, and if I'm humble, then there's nothing else I'll do with that. Well, I started off as a software developer. I left school with a master's degree in computer science, thinking I would be a software developer the rest of my life. And so I wrote compilers. I designed languages and wrote compilers for a couple of years at United Technologies in Colorado Springs, Colorado. I looked at Tim because Tim knows where that is. That's right. Yeah, and I joined Oracle in 1989. I was in a software development group where we had a PhD. My plan was to become a PhD in computer science. And I kept looking at this guy just about 3 cubicles down and thinking, why do I want to break my back to become that guy? Because he's sitting in the same kind of cubicle I'm sitting in. And so I kind of abandoned my PhD dream. And instead I came to Dallas and went to SMU for a year, got my MBA. And as soon as I got my MBA done, I had an interview with a company I'd never heard of before the week I interviewed with them, called Oracle. And I got hired as a FinApps consultant. I guess the thought was that even though I had a computer science background, I was trying to escape that by the MBA. So the guy that hired me thought I'd be happy installing and configuring Oracle financials. And
he knew they'd need a programmer around for that, right?
Yeah, it turned out that was the lucky part. So I ended up at a lot of places that were really a mess, and the thing that I kind of gravitated toward was the performance aspect, because all these early FinApps customers had so many performance problems. The product really wasn't quite ready yet, and it was being very aggressively positioned. So anyway, I kind of spent a couple of years flying 40 weeks a year doing consulting, and spending another probably 8 weeks a year teaching other people in Oracle how to do the things that I was learning how to do out in the field. And then started taking on people around 95 or so. By the time I left Oracle in 99, I was a VP. I had 100 people working for me. and went off and started a company, and then in 2004 started another one, and here I am.
Okay, and you and I crossed paths very early in your career because I was starting about the same time you were, and we sort of wound up at some of the same clients.
Yep.
In downtown Dallas, so that was kind of interesting that we knew each other that long back, and then our paths again.
Interfirst Bank, I think it was called.
Yeah, or
90.
NCNB, I think was.
Yeah, it was NCNB Texas for a while.
Yeah.
Yeah.
Anyway, okay, so that's good. As a performance guy, one of the things that a lot of people, I sense from a lot of people when they're looking at Exadata, the long-term performance guys tend to have, to some degree, resistance to the architecture and the hardware platform, the engineered system thing. And I think part of that is because we, as performance guys, we tend to think that throwing a new platform at a performance problem is not really ultimately a solution to the problem, right? It's almost like a Band-Aid in some ways. And so you and I have talked about this before, but I sometimes think about the job that we do as being sort of like the medical field where, there's different kinds of doctors, right? There's the guys that are the OR doctors, that the emergency room doctors that, when you come in, their job really is just to keep you alive long enough to get you to the operating room where the guy that's a surgeon can actually fix you. Right, and then there's the guy after you get done being fixed, which, by the way, is very destructive a lot of times. They have to cut into you and do all kinds of nasty stuff that's also difficult to recover from. And then there's the guy after you get out of the hospital that you go to that says, well, really we need to fix your diet and get you on an exercise plan, all that sort of thing.
Right. And
so, in a lot of cases, I find myself on the front end of that, of the emergency room doctor, where I'm just trying to keep people alive long enough, to get to the root problem of it. And I'm fairly comfortable with that, but I don't know that you are. So I think I'll, ask you, where do you see yourself on that spectrum, and how do you feel about that?
Yeah, the place I've been on that spectrum has really changed over the years. When I was at Oracle, I was very much, I was almost a triage guy, maybe even before the ER. The 40 weeks a year I said that I spent on the road before, those were 40 different customer sites that I'd see each year. I'd go to a different place for 3 or 4 or 5 days and then go home. And the goal really was just to stop whatever hemorrhaging was causing a business not to be able to perform on the hardware and the software that they had chosen. So for 4 or 5 years, I really never saw a company more than a week, and then I was gone. Later, I really kind of became more of a part of bigger projects. I think the last project I did when I was at Oracle, it was at a hard disk manufacturer out in Southern California that was having a really serious problem with performance with Oracle manufacturing. They had pallets full of stuff they couldn't ship because they couldn't print the labels quickly enough to get them out the door, and UPS and FedEx guys sitting on the back of the truck with their legs swinging, and I nothing to do. There's pallets of stuff that need to be gone. There's angry customers calling saying, "Where's my stuff? It's supposed to be here 4 days ago." But the stuff couldn't go anywhere because they couldn't get the labels put on the boxes because the labels wouldn't print because the apps wouldn't print them, and things like that. So places like that later in my career, I spent 4, 5, 6 weeks trying to get everything ironed out. And then in the last, I'd say last 10 or 15 years, I've really been trying to focus on moving upstream to try to help people make their applications so that they're sustainably high performance, instead of having these, hit the tree and the airbag deploys and then try to figure out, well, how do I keep that from happening again? Trying to make applications so that they just work better. You mentioned the Exadata architecture and kind of a resistance. I think the right word is a cynicism. I think that people that have dealt with software performance for a really long time kind of feel like, well, here's another one. Every vendor, we hear their new box comes out, and they always say the same thing about, well, this is going to make performance problems go away. And Exadata is really the first kind of whole stack architecture that really kind of has a shot at doing that. And the mythology and the hype around it is so big. The first real awareness that I had about the mythology around Exadata, I was in Utah, and I didn't tell you this in your office, so he's sitting there going, this is off the script.
Not that this is all scripted.
Not that this is all scripted at all.
But I did have a list of questions.
I remember at a UTOUG in Salt Lake a couple of years ago, I was given a presentation and I showed an Exadata trace file. And there were 100 people in the audience kind of spread out, and it was one of these live, you can ask me anything you want to know kind of presentations that really was unscripted. And this lady stuck her hand up, and I said, yes, ma'am. And she said, why on earth are you looking at an Exadata trace file? And I said, well, what do you mean? And she said, well, I mean, trace files are about performance, right? I said, yes, ma'am. She said, well, how could an Exadata box ever have a performance problem? And I thought, really? And so the next thing I did was I said, well, how many of you have actually own an Exadata box? And no hands went up. And I said, how many of you have actually ever even sat down on an Exadata box and ever seen a real live demo? No hands went up. And I thought, okay, this is the wave. It's like when the bomb blasts, you know, and that shock wave goes out before the real fire and all that comes. I realized I was in that blast zone where the fire hadn't gotten there yet, but the word about the fire had. You know, the knowledge that Exadata was going to completely solve all performance problems forever had reached these folks. And this lady was earnestly, genuinely confused about why any performance person would ever need to approach a room with an Exadata in it.
Yeah. So the thought was it was an appliance and they wouldn't need to do anything except just turn it on, it would run, right?
And it's so powerful that there's no way you could bring it to its needs. Yeah. And so that's the thing. The thing is that, yeah, if you buy a $3 million box and put a little departmental application on it, it's going to scream. I mean, it's just going to absolutely roast, you know, and you never will have a performance problem with it. Problem is, like any other box, you're going to try to get the maximum economic benefit out of the box. You're going to fill it with load. And when you fill a big, complicated box with load, it's going to act just like a little box that's full with load. And there are ways that you can bring anything to its needs. I mean, if you're accustomed to taking packages across town in a truck, and somebody gives you a bigger truck, well, that's great. But if you fill the bigger truck, then you have the same problem you had when the little truck filled up. And if you buy a 747 and fill it up, you've got a harder problem, because 747s, you know, making 2 of those is a harder problem than making 2 trucks. So the bigger things get, the more complex and difficult things get when they fill up.
Yeah. And so I often tell people, hey, this is just an Oracle database running on this machine, right? So it's got just as many knobs and switches and you know, control mechanisms as any other Oracle database, right? It's no different. Right. And in many cases, you do have a lot of applications trying to share that, you know, that resource, and which always makes it more difficult.
Exactly. And the most complicated control panel on that thing is really not the init-Aura stuff or the centralized stuff. It's the apps. I mean, here's a thing that you can put any code path you can imagine on it, and some people have quite disturbing imaginations when it comes to what they can do with their code path.
So can you remember what your first impression was the first time you heard about Exadata?
I can't.
That, and then follow on to that would be the first time you actually got to sit down and play with one. But let's start with what you first thought about.
The first time I even heard about it was either an Oracle ACE Director briefing or Oracle Open World. What would it have been, 2009 or so?
Yeah, something like that.
When the HP V1 Exadata came out, and I remember having kind of a split brain about it. The hardware side, I was kind of like, you know, it's faster hardware. There's always faster hardware every year. That's cool, but you know, it's just the same as 3 years ago, except the numbers are different. But the magnitude of a jump seemed about the same as magnitudes of jumps that I'd seen before. So I didn't really, from that perspective, understand what all the hype was about. The thing that I thought was really exciting was the smart scan stuff. The key to optimizing almost every system I've ever seen has been that most systems do more work than their business needs them to do. They actually do a bunch of work, and at the very end, they either present too much data to the client has to, in somebody's brain, throw away rows that they really never wanted to begin with, or the application kind of carries rows through a way too expensive execution plan, and at the very end does some kind of filtering operation that only shows you 4 things, but took an hour and a half to produce because it carried all these rows through all this processing that really should have been discarded earlier. So in optimization that I've seen over the past 20 some odd years, the the most effective way to do it is to push that filtering as deep into the software as you can, as early into the plan as you can. And generically, that's the filter early pattern, right? Don't carry around work that you don't need. And Exadata came out with this idea of, well, we're not even going to return blocks from the disk into the buffer cache unless we know that they're absolutely necessary to perform the operation that's being requested. And then, the columnar projection stuff where we're not even going to get the other columns that you don't need. We're just going to get that set of 3 columns out of this table, and that's all the data transfer we're going to do. I thought that was the coolest thing in the world. And the really neat thing, the reason that they could do that, I guess, was that the engineering staff from Oracle was working with the engineering staff from the hardware company and pushing that code path all the way down into the storage cell. So I thought that was really cool.
Yeah. You're right. I agree with you.
Yeah. And then
so tell me now what when you actually got to sit down and log on to one and play with it, how you felt about it a little bit.
Which was in your office that took place, and thank you, by the way, for that. Otherwise, I still probably wouldn't have had my hands on one. What do we have in that class? About 7 or 8 people, I think. Tim,
something like that.
Something like that. And the experience is really pretty interesting because the folks that were in the room are folks that know how to create load that a system can't handle. And I was really surprised. The first few examples, Tim Fox, I guess he's next on the agenda, gave us some really interesting problems where we thought we were going to be able to overwhelm this machine. And I look back through my tweet stream like he suggested, and you can see the excitement as we were trying to kill this machine. It was hard. It was really difficult to make this thing come down to its knees. Now, of course, it's
eventually
not impossible.
Eventually you were successful, right?
The one knob, the degree of parallelism knob, is one way that you can kill a machine pretty much of any size. So we ended up doing it. But I was very impressed at just the pipe. I mean, the fatness of the pipe between the storage and the database buffer cache was really, really impressive. So kind of the skepticism I had with the hardware became like whoa, this really is different. And then the software stuff was just absolutely incredible because, all the filtering that's done way, way, way down inside the storage cells was really neat. Now, the scary thing, and this is something that the tweets reminded me of, and I still have this kind of almost like it's the dark cloud in my head, is it is intensely difficult to predict what the performance of a particular operation on an Exadata is going to be because of all these clever features that sometimes engage and sometimes won't. And I remember going through class with a lot of really smart people, Jeff Holt and Ron Crisco and some of my guys. I remember being just absolutely baffled. We'd do an experiment, we thought we knew what was going to happen, and it wouldn't happen that way, and Tim would be up there with kind of the slanted smile because it happens every class because he knows that people get stuck on this. And then we'd have to go back and review, now, when does the smart scan kick in? And we'd have to recite the conditions under which it would. And later when we got to storage indexes, it got even trickier. So I remember feeling like, oh my gosh, this thing, it's scary because it could be so awesome, and yet you change one little thing and don't even realize you made a change, and suddenly you've got from 0.04 seconds to 40 seconds again. Yeah. And I found that somewhat unsettling. So I think that probably that's some of the early shakeout types of things. I doubt it'll be that way in a year or two.
Yeah. Well, and it's certainly better now than it was a couple of years ago. But I'd have to agree with you, particularly the storage indexes. There's not a lot of, they haven't built a lot of control into storage indexes, right? So we can't really tell Oracle, I really want you to, use these 8 columns and always use these 8 columns, right? Which was I think you were in that ACE director briefing where somebody, might have been Jonathan, asked, hey, are we going to have any hints or any sort of control mechanism on the storage indexes? And the guy said, no, we're not going to. Yeah, we're not. Yeah, it was Alex. Alex, I think, asked that question, and they said, no, that's something that we're going to decide, and we'll do it for you, and you don't really need to know that. But it is a little frustrating, right? If you get it one time and it's a sub-second response time, then the next time you try it, it's not. So.
Exactly, and it's just some reboot. User does something on Wednesday and it takes 0.04 seconds, and then all of a sudden they come back on Thursday, and unbeknownst to him, why it could ever happen, something might take 20 seconds again, and it's just. Exactly. Yeah. It's the Tom Kite's famous when the guy rides his bike to work, the system's fast, but when it rains, the system's slow.
Right.
You know, and there ends up being this subtle thing that happens behaviorally because of that.
Yeah. Generally speaking, a lot of you guys already have Exadata, so generally speaking, I'd say that once the systems get up and running, it's probably not as big of a problem as we think it might be, because the workload, those storage cells don't get rebooted very often, and so they don't really tend to get flushed out that often. But yeah, the opportunity is there, and if you don't know how to look, it's difficult sometimes to understand why it would be so fast one time and not so fast the next time. Let me look back at my notes here and see what else I was going to ask.
Did it get slightly darker while we were talking? Or
yes, it did. I thought it was just me, but
I thought you were just tanning.
It was the audience being pessimistic and upset.
Yeah, that's what it was.
Yeah. So I guess as long as we're talking about the ACE directors meeting, how do you feel about the fact that documentation for Exadata is not generally available to the public? Which is kind of a setup question. But
yeah, it is. I think it's a big mistake, because I think that people like the folks in this room are very important in the Oracle ecosystem. Just the patterns repeated itself that I started in back in the late 80s. I mean, the documentation and the product were good enough to do a lot of real good in the marketplace, but the fact that there wasn't a lot of knowledge about the internals of how things work or how you could optimize it really diminished the value that the products had at a lot of places. And so this little subculture grew up with people like me and you and Tim Gorman and the other really, really old people in the room. We couldn't have really existed without having our hands on this thing. Mm-hmm. And there's really two levels of hands-on. One is studying the heck out of it, and then two is actually going in and now finding out did the things that I expect from having read the documentation actually behave that way. And if you can't even get up the first step, I don't know how you can get to the second step. So for me personally, I think in a bunch of people in this room, I mean, you guys, by purchasing an Exadata box and giving access to it, have been the only kind of little corner of light where the solution can take place. And I know, for example, me having my hands on it, if you can't get to the dock and you can't get to the machine, I don't know how you can really learn about how to push it as far as it can go. And from a company perspective, I feel like Oracle's probably not fulfilling as much of the potential of the machine as they could if they were.
Do you think they would sell more if they released the documentation and made access a little more easy, or do you think
I can't imagine that it wouldn't help that. And again, we kind of got off. If you look at the proportion of time I spent talking about dark cloud stuff a minute ago, that's not my overall impression. I mean, my overall impression of the machine is wow, this thing is enormously capable of doing things that you can't do any other way. But you do have to have certain, you have to use it correctly, right? It's not just, yeah, you can roll it in and get, I forget what the statistics are, but like 6 times better performance if you just roll the thing in, and a lot of things will just run faster. Mm-hmm. And a lot of people are probably satisfied enough with that they quit. And I find that frustrating sometimes, and I know you and I have talked about it. Mm-hmm. Well, you might have a 10,000 times faster opportunity if you just spend an extra 15 minutes understanding how this thing works. So yeah, I got 6x, but I could have got 10,000 on 2 or 3 key areas of my application. And a lot of people will probably go through their deployment and production run with the Exadata box and never really even understand that opportunity exists. And I think...
So why does that bother you?
I'm a plate cleaner, I don't know what it is that my family might describe it as they don't know what's wrong with me, but when I have $10, I want to get $10 of the value out of it. Actually, I want to get $12 of the value out of it. And if you can be smart, you can find ways that you can exploit your investments to bring better returns.
Yeah, I don't know if everybody got the plate cleaner thing, but Carrie's family is like, you don't have to eat everything on your plate every single meal. And Carrie's like, yes, I do.
For some reason, I just have to. And I hate to see people purchase things and not get every drop of benefit out of it that they can. Genetic defect, let's call that.
Yeah. So one of the things that you and I had talked about previously too was the morphine effect of Exadata. You know, you've got a really bad performance problem that's causing you a lot of problems. You roll the Exadata in, drop the app on it, really don't make any changes to the app, but you just run it and you get some relief and some benefit from it, right?
Right.
And so we talked about why that bothers you, and it's not just the compulsive, I need to get every dollar out of it. There's also another reason, right? So
yes, there is, Cary. No, that's a real good interview guy. Yeah, and the thing that it brings to mind is, nobody's going to buy this huge box. Imagine the box the size of the screen, the capacity of the hardware, and just put this many pixels worth of workload in it. What people are going to do is they're going to fill the box. Somebody's going to say, hey, if that application became 6 times faster, we're going to add this other departmental application. And some other manager goes, oh, we're going to put our thing on there too. And then somebody gets the bright idea, hey, we're going to build a whole new web presence and we're going to host it on this Exadata box because everything on the Exadata box is fast. Well, over time, you end up filling in all the pixels that this screen can handle, right? You end up putting as much load on the box as you can, and suddenly now you've got a machine that's this big, or in Exadata's case is that big, but the load fills it. In any system, I don't care if your highway's got 38 lanes in it, you can fill it. There is a number of cars that you can put on the highway that'll fill even a 38 or even 138 lane highway. And as big as Exadata is in terms of capacity, you can fill it. And when you fill it, what happens is you have to either scale to an even bigger machine, or go horizontal and rack them together or whatever. But that's expensive compared to maybe there's a 4-hour project that when you first put that little application on that turned into a bigger application, it turned into 16 applications. Maybe each of those applications has some optimizations that could be very inexpensively performed. Very, in some cases, like 15 minutes of the right person looking at it, flip it, and ta-da. Now you've got lots of pixels left over that you can grow back into. And my impression is that gets more difficult over time. If when you port the thing or when you move the thing to the Exadata box, if you make the application optimal and then let it sit there for 2 or 3 years and forget about it, it's much easier to optimize when you're familiar with the moving of the code than if you sit there and just kind of forget about it for 2 or 3 years until suddenly you've got a problem and don't really even know where to go get your finger on it.
Yeah, so you just let the problem fester until it becomes much bigger, and then it's harder to solve at the end is sort of the fear of it. Let's see, what else did I have on my list here to ask you about?
Well, that's of course Exadata 3 will be.
Of course.
Exactly. And I wrestle with whether that's good enough. The comment was by that time Exadata 3 will be available and we'll be able to get 6 more. And it just seems to me like the old cartoon where the train's going down the track and there's a guy that's laying track just as the train is approaching it. So there's a risk, I guess, that you won't be able to lay the track quickly enough, or that you won't be able to afford to lay the track that quickly. Every one of these remigrations is it's a project. Right? It isn't just
So then you go to Hadoop, right?
Well, yeah, that doesn't require any code changes or anything, does it? Yeah, running e-business on Hadoop. But we probably ought to be able to have that done if you turn this into a workshop, we could probably all have it done by tomorrow afternoon.
Probably. Crystal, you had a question.
Yeah, Kerry, so why do you see that as a problem? Why throwing hardware if the hardware can keep up? Sometimes large organizations have particular tools choosing and listening to the right person, even if the solution is in place.
Right.
Sometimes the person that is there doesn't have the credibility, doesn't have the political aspects, and etc. And those 4 hours, whether they're done or not, whether they're done correctly or not, or whether the solution is implemented or not, sometimes it never happens, and it's easier for the organization to just spend the money on the hardware. If that solves the problem, great. If not, then we're going to look at the 4 hours or whatever.
Yeah, I hear that, and I wrestle with that. And what it comes down to me is, what's the most efficient thing that you could do to solve the problem? And I know that a lot of companies don't behave in the efficient way. it used to drive me crazy in these 40 visits a year that I'd go to. I had a couple of ideas that I really went home proud that I'd come up with. You know, the week where you tell somebody, look, if you drop these 5 indexes, create these 3, this will be better, that'll be better, that'll be better, your backups will be better, your redo will be less, all these things will happen. You write all that down and then see the same folks 3 months later at a conference and you go, hey, how'd that turn the 5 indexes into 3 thing work out for you? And they kind of look at their shoes and go, well, we couldn't get that done.
Or worse yet, you know, somebody else, me, follows behind you 2 years later, gives them the same report and says create the same 5 indexes, drop the same 3 indexes because they didn't listen to any of yours, and then they've got the recommendation from yet another guy.
Right.
And a year later you're back in there and it's like, well, I told you this and Kerry told you that and you still haven't done any of it, right?
And that happens all the time. And then on the other channel, you kind of walk in, it's like, what's in the crate? Well, we've got a new box. Well, what are you going to do with the new box? Oh, we're going to rehost our apps on that new box. And you just think, wow, how long is that going to take? How long would it have taken to drop 5 indexes and create 3? And so I see it all the time. And I do wrestle with, sometimes, I mean, basically what you said, Christo, was that that 4 hours might be way more expensive than I'm assigning a cost to. Because if I put Karen Morton in, or put you in, and 4 hours of that person's probably going to result in a revolutionary experience for the customer. But a lot of times customers have tried that, and they've done it with maybe the wrong person. And that 4 hours produced maybe a net negative. Yeah, it might have turned into 4 months of T&M that never produced a single result. And I know a lot of people have gone through that.
Well, the other thing I think he was saying was sometimes it's impossible to get the guy in there for 4 hours. It's just politically not possible, right?
Right.
Whereas, you know, putting a new platform in is politically possible. And
exactly.
So I think he's right. In many cases, you know, you do what you can do, right? And if it gives you enough pain relief to, you know, make it palatable for a while, then I think that's okay. You know, it's maybe not doing the heart surgery and really fixing the guy's heart, but you know, it's keeping him alive by giving him a baby aspirin, so at least the blood's a little thinner, right?
Right. Go ahead.
Essentially, the bigger the company, the more Exadata is relevant to the company. But the bigger the company, the less they care about efficiency, the more they care about effectiveness, right? So
Right. Is now a good time to tell you the plant story?
Sure.
Does that fit? You remember the thing about...
I don't remember the plant story, but go ahead.
Oh, sure you do. These 40 weeks a year I used to travel. You know, I'd leave my heat on in the apartment until about 85. And I had this plant that loved it. I mean, it loved when I was gone because the apartment's 85 and, you know. So what I'd do every week when I got home is I'd throw a little Miracle Grow and some water in this pot, and I'd come home and the thing would be 5 or 8 inches taller by the time I got home. Well, one time I got home and the top of this thing was bent over because it had so many leaves and flowers at the top. And I thought, man, this thing's going to break if I don't give it some assistance. So I went and I got a yardstick and some twist ties. And I basically yardsticked the trunk. I twist tied the yardstick to the trunk so this thing would stand up straight. And I hit it with some Miracle Grow and some water. And I fully expected that when I got home, the trunk would be bigger this way and be able to support itself. And so I went on the road for another week, and when I got home, what had happened was the plant, I really felt taken advantage of. I was really ticked off at this plant. What the plant did was it sent all that resource I gave it up to the top where, you know, with the yardstick, it could hold more stuff up there. And I got ticked off. I took the yardstick off, and the thing bent, and it broke. And I just cut the thing off. I'm like, that'll teach you. And the metaphor that put in my mind was that if you artificially support something in a way that's not sustainable, because I mean, I'm not going to have a yardstick strapped to my plant the next time I have company over,
just need
right?
a bigger yardstick,
I guess. And that's kind of what it reminds me of. If you end up sort of becoming dependent upon, well, yeah, I'll have bigger hardware in 18 months, and I'll have bigger hardware than that in 18 more months, there comes a time where you may not, like I said, you may not be able to support your business on that. And I don't know what it is.
But you'd have had all the flowers.
Yeah, I know. Oh my goodness. Oh my goodness.
What do you think about the engineered system part of it? The fact that, you know, it's pre-engineered by Oracle, all the parts are put together, and we don't have to figure all that stuff out.
I think that's awesome. Going back to kind of harking back to the early 90s when I used to have to call, one application development group in Oracle, and they'd point me to another, and then that would point me to an operating system vendor, and then I'd have to go talk to a SAN vendor, and then I'd have to go talk to a network vendor. I mean, all that finger pointing stuff is just gone. And I think that much like Apple, managing the whole stack inside of a Mac computer with the OS and the hardware integrated together, I think it's fantastic. And then going back to the storage cell offloading type stuff, I mean, I know Oracle and HP kind of work together to do that, but I feel like the relationship became really more, completely effective when the groups all carry around the same logo on their name badge. I think that's fantastic. I mean, just this, the whole stack support, if nothing else. Plus, it gives opportunities for optimizations that just aren't possible any other way.
You mentioned Apple.
Uh-huh.
I once have heard from an engineer in the Netherlands that, there are two sides inside Oracle. One side says, what's the Apple approach? You can't change anything.
Uh-huh.
Everything is in control. On the other hand, is what they do currently. You can tweak things yourself.
Right.
I found it a little bit frustrating. I mean, we had all kinds of problems due to bugs.
Right.
Then an engineer said, we have two sides inside Oracle, and one side says the Apple approach, as if most problems are caused by us.
Right.
Which is not the case.
Well, and certainly it's really frustrating if you can't pop open the case, but there's a problem, then that puts more onus upon the vendor to basically take care of you. I mean, if the vendor's saying, no, I'm not going to let you in there, then obviously the vendor has to take care of things swiftly and responsibly. And we're talking out of both sides of our mouth about it already, because the storage index thing is a place where we can't take the cover off.
Right.
And there's a lot of, at the Oracle ACE meetings and things, a lot of stimulus from the audience is like, hey, we need knobs. We at least need to be able to, kind of force it to put the one back on that was on there last week. Even though the workload, warm-up may not look like to the database that the same storage index needs to be there. We kind of know our workload better than the system can at this point. So, it's more work on the vendor. I'll put it that way.
Yeah.
To keep the case.
I do think it makes support's job quite a bit easier, right? Because Oracle for years has had, this sort of best of breed sort of approach, and so anytime anybody calls into Oracle support, it's like, well, I got this kind of hardware with this kind of SAN, with this kind of an HPA, with this, which makes it very difficult for the Oracle support guys. And at least, with an engineered system, they know what you got, right? So it's a lot easier for them probably to help you resolve problems.
I think it makes some impossible things possible.
Yeah.
I mean, that's the easiness comes into the realm of can do it effectively at all.
Yeah. Yes, Tim.
Okay.
Now we can hear you.
We'll repeat it.
Hello?
Oh.
Sneaky. I wonder, just as a question, whether you have a sense that Exadata is kind of, two views, I think, to this. Do you think Exadata is a path on an evolution, towards a converging point? Or do you feel that there's some kind of long wave going on? I mean, a few years ago, I think 10 years ago, 20 years ago, we might have really been talking about open systems and best of breed and everything like that. And now we're talking engineered systems. So do you feel there's something of a long wave going on and that we're at this point on a wave towards engineered systems where we might have been, say, 35 years ago when we were talking AS400, you know?
I absolutely think that there's a long, wave cycle going on. That's
not a convergence towards some great future.
No, I think it's sort of I think of it as a pendulum swing. We were way over there, back in the early days with IBM, where everything was all, one manufacturer stack. Then we swung way over this way on best of breed everything, right? It's the software, the hardware, everything was all, I'm buying this from him and that from that, but we spent an awful lot of money and time on the integration of those things, right? And so now I think that pendulum's kind of swinging back the other direction again. Hey, maybe a pre-built system is not such a bad idea. I don't have to do all that integration work and risk that I did something wrong in the integration which causes me outages, on my production system at some point down the road.
I think it's a long wave too, and I think the instructive thing to think about is why did we go from the one we were at to the one we're going to now, and then think in terms of why would we go back? What causes the direction change when we trough or peak? And I remember back, 1990, the big most of the places I went to had some kind of IBM mainframe in the bag. And the people that were installing Oracle were just fed up with not being able to get any responsiveness from the people that surrounded this IBM mainframe. It's basically a ringed city, and nobody could get their workload on this thing. And the open systems promise was, well, you can run anything you want, anytime you want. You can run as much as you want. And the fact that there were no controls on how much workload to run on these things caused a lot of them to perform very badly. Because you can fill any box with more load than it can handle, and then it becomes a performance problem. So kind of the swing back into the engineered systems is exactly what we're talking about. It costs an awful lot to put together a really harmonious, well-balanced system that software is aware of all the capabilities that the hardware can provide all the way down to the deepest level in the hardware stack. And it's much more efficient for a single vendor to invest all that time and energy into doing it right than it is for everybody out in the world to try to figure out how to do it themselves.
Right, for one-off, right? So
yeah,
that's the difficult part, is no repeatability, right? If you're just doing it for your company, then that's not going to be, the guy next door is not going to have access to that. So it's a lot more cost-effective, I think.
But now kind of at the same time, you've got the extreme of Google and Yahoo building their own machines that aren't anything like a machine you can go buy, because they don't need the kind of machines that we go out and buy.
And I think those guys are pretty exceptional, though, right? Google is a software company. That's what they do for a living, really.
Right.
So,
but if you think in terms of just the pie chart of how many systems are engineered versus, well, I guess those are engineered too. Mm-hmm. So I'll retract.
And by the way, on the engineered system thing, when I think about Exadata, engineered system is way low on the list of advantages of it, in my opinion. To my way of thinking, it's that storage software that gives us a whole new way of processing data, right? That's where most of the value is. The engineered system is sort of a sideline benefit, but that's certainly not one of the things I would put high on my list.
I'd agree with that.
Can I just ask you one question about engineered systems? We've had some customers, and they were actually afraid to move to Exadata because they were afraid of a vendor lock-in by Oracle. What's your opinion on that?
Well, you certainly have to trust your vendor to go that deep with them. And what do you have to say to that?
I agree with you 100%. It's completely a trust issue, right? If you don't trust the vendor, you're not going to go with a complete stack that every single piece of it is theirs. I don't know. So our Incatech, the company Incatech, is an Oracle-only company. So we only do work on Oracle systems, and we get that question fairly regularly. How come you guys only do Oracle? Doesn't that put you in a bad position because you don't have, some other way to sort of keep the Oracle guys honest that you're dealing with? And there's real pluses and minuses, right? The plus is the Oracle guys really like us because that's all we do, right? So they're not afraid that we're going to go in and pitch somebody else's solution to a customer. On the other hand, we do give up some ability to bow up against them, if we're unhappy with something. But I think we're better off, having a close relationship with that vendor than we are having an adversarial relationship. So, Tim?
No, I just had a funny experience at a large financial institution recently. It was the usual debate between developers and DBAs about database portability. We have to write our applications so that we can port across different databases and such. And these were Java developers. And then one of their points was, well, we can't get locked into a single vendor like Oracle. Java developers. Do you understand?
I think one of the advantages for the engineered systems that you might not initially see is the fact that putting together your own hardware and software takes a great deal of expertise within your company. Right. And that effort is not generally viewed favorably by higher management because of the costs and the timelines. What the Exadata buys you in a lot of cases is you did exactly get that balance between disk storage, between InfiniBand network, and between rack nodes, and you did buy it exactly the way you put it. It's just a side advantage, but it turns out to have long-term benefits in terms of the scalability of the system as a whole.
Yep, absolutely.
Yep.
I think on the lock-in problem, Exadata runs an Oracle database. How are you locked into Exadata? You just buy a different box and you port an Oracle database.
Yeah.
Right.
So that's the smallest possible amount of lock-in that you've got.
Yeah, but if you have some question, for example.
Yeah, but that's just the
we take
volume of
out
hardware. I mean,
Exadata.
that's just the volume of hardware. That's not lock-in. That's finding the thing which is the most cost-effective solution to what you want to do. If you really need to cram your data into that small space, Oracle's the only current supplier. If it's just a question of manipulating data, well, hell, expand it out again and put it on a bigger set of disks.
Yeah.
Sorry, that's a theoretical argument. That's not my personal opinion. Not necessarily my personal opinion.
If you would, the live audience here, if you'd use the microphones, we have a group, I should have said in the introduction, a group about as large as you guys online. And so they're asking back in the back here, they can't hear the question. So if you'd use the mic, this is live to the folks online. So next question, I think.
So you had a number of criticisms about what I guess would categorize as messaging, you know, the myths, the lack of documentation. So if you're sitting in the room with the head of marketing, what would you change? What would you suggest, and what would be the medium?
Yeah, for me, just transparency, I think, is the number one thing, because what they've got here really is spectacular. I mean, the Exadata box, it's phenomenally good. And I know one of the questions Kerry's going to ask me in a minute, I'm not going to give him a chance. Is it a quantum leap, or is it just kind of the next little bit better thing? I think there's quite a gap between what was before Exadata and what is. And I'm hopeful that it will become more mainstream where, you know, I can envision a world maybe 10 years from now where the only thing that Oracle sells is Exadata boxes. And they got little ones for people that have $50,000 budgets and big ones for people that have $50 million budgets. But the software has the potential to be useful for everybody that runs Oracle presently. But I think that because it's so good and so awesome, really, there's nothing really that Oracle need to hold back or hide. And so I feel like it's probably, that would be my advice, is just to be more open. Including, I know a lot of people don't have access to see how these things work. And I know it's an expensive proposition for Oracle to say, hey, log into this EC2 Exadata, cluster and have a half hour. That'd be cool. I don't know how cost effective that is for Oracle, but the ability to get your hands on this thing, for me, it turned me from mostly cynical into, just kind of like wobbly in the knees. There are things that need to be done. There's still room for the Tunnell, Jonathan Lewis, Cary, Osborne. There's lots to do, and I think the sooner that people get on it, the better and more quickly the platform's going to evolve into being even more awesome.
Yeah, even I would add to that and say even the Oracle guys, the guys that are pre-sales guys at Oracle, have very little access to these things, right? Which is, to my way of thinking, is ridiculous, right? You're hiring technical guys to go out and talk to customers, and yet they don't even have the opportunity to play around with the technology. So I know it's an expensive proposition to make that available, but I think it's critical. I don't know how you can expect those guys to do their job without it.
This is a comment about the single Oracle stack, about being logged into a single stack. Actually, I see it as an advantage. Having worked for 17 years as a DBA, I see that the finger pointing goes on when there's any kind of problem between the multiple vendors. So I think this is a more like an advantage to actually choke one throat in a single Oracle stack. Because at the end of the day, you are responsible for performance, upkeep, and stability. So why not have one vendor supply everything?
Yeah, I think we're in agreement on that we think it's better than having the alternative solution. So.
A question for you guys. This is some really experienced and bright people in the room. Has any of you ever seen an application that was built to run on multiple databases that actually worked very well? So you're kind of locked in anyway, right? From the perspective of, can you just take your app and run it on something different from Oracle? Not really. And if you can, I'm betting that you're not real happy with the way it's running now.
Yep.
So that, it's almost, that's just part of the landscape. There is some lock-in already.
Yeah, I agree with that. Well, we're about out of time, guys, so we got time for maybe one more question, and then we'll wrap it up.
Besides documentation, what are the top 3 things that Oracle needs to improve the adoption rate?
You first.
All right. If we could make it a little cheaper, that'd be awesome. That's one thing. I truly believe that if the documentation and access to that platform was more available, they would sell a whole bunch of them. So I don't think there is any other thing that's even close to that, to be honest. Because when we have guys come into our office and sit down and play with the thing, and we do a lot of POCs or POVs, if you want to call them that, where people will come in, bring a few terabytes of data, and run some part of their application on it. And they always go through this death and dying curve kind of a thing, right? It's like they run something that basically won't finish on their current platform, and they start taking notes. Right, I'm going to start this. I'm going to write down what time I started it, and then we're going to see how long it takes. And they look back up, and it's done. And it's like, well, that couldn't possibly have worked, right? It must be broken. So they go through this denial, right? That's not working. They go through a getting angry phase, then they go through an acceptance phase, finally. And so I just think, the more people that you can get to actually log on to one of these things, I think the more of them you'll sell. And I agree with Cary that this is a long-term change in Oracle software, and I fully expect that at some point in the future, I don't know when, but most of the Oracle systems will be running with the Exadata storage because it's that significant of a difference. So, great last question. Thank you. I think that's all the time we've got. It's coffee break time, and Kerry and I will be around, so we'll be happy to talk about anything else. Thank you.